Alright, a curve is defined by this. We want to find the equation of the tangent at a given point. Okay, so the main thing to remember here is that the slope of the tangent, well, that is just dy dx. That's the definition. That's where dy dx came from. Came from the slope of the tangent. The other thing to remember is, if we're looking for the equation, that a tangent is just a straight line. So the equation of the tangent usually is y minus y1 equals m into x minus x1. So in order to fill in the equation, we need to have a point on it and have the slope. We're given a point on it, x1, y1 up here. Right, so that's my point on the line. So what we need to do now is find the slope of the tangent. In other words, we need to find the derivative. So we are going to do implicit differentiation. The reason we're going to do implicit differentiation is that when you look at it, the x's and the y's are all kind of mixed in together. We don't have y equals blah blah blah. We have lots of x's and lots of y's all mixed in. So we're going to differentiate everything. So we differentiate 3x squared and we get 6x. That's not a problem. Now we're going to come back to this because here we have an x multiplied by a y squared. We're going to need to use a product rule. So we'll come back to that in a minute. And over here we're differentiating y cubed. Now, if you think about it, when you differentiate 3x squared, you have the 3 there, right? That's fine. You bring the 2 down, so you get 3 by 2, that's the 6. You get x to the power of 1, that's fine. And then you could say to yourself, well, I'm going to multiply by the derivative of whatever's left. And whatever's left, if you can see it just there between my thumb and forefinger, whatever's left is an x. When you differentiate x, you get 1. Right, so this is 6x by 1. It's slightly different over here. So I differentiate y cubed, I get 3 times y squared. If I cover that and I differentiate what's inside the cube function, I'm differentiating y. When I differentiate y, I get dy dx. Alright, so each time you differentiate something that has a y in it, you need to multiply by dy dx, and that's the chain rule coming in again. When I differentiate 1, I get 0. Alright, now back to this x by y square bit, I'm going to need to use the product rule. This is u by v, so u is equal to x, so du dx is equal to 1 when I differentiate x. V is equal to y squared, so when I differentiate y squared, I get 2y. And then if I cover the squared, I need to differentiate a y. When I differentiate a y, I get dy dx. So if we fill all this in, so I have u times dv dx plus v times du dx. So when I fill it in, I get 6x minus u times, so x times dv dx, which is 2y dy dx, plus v, which is y squared, times du dx, and du dx is just 1, plus 3y squared dy dx, that was there already, equals 0. Alright, so we filled these, the red ones here, into the formula to get this. Now we're going to multiply out the bracket, minus 2xy dy dx. Oops. We have a minus here, so we need to be careful to multiply it into everything. So we get minus y squared plus 3y squared dy dx equals 0. Now at this point, you're pretty much done with finding dy dx. You've done all the hard work. What you need to do now is each term that has a dy dx in it, leave it on the left hand side. So we get minus 2xy dy dx plus 3y squared dy dx. And any term without a dy dx, we stick it over to the right hand side. So we get, with this, we add y squared to both sides, or bring it across really, we should think of adding y squared to both sides. So we should end up with y squared minus 6x on the right hand side. There's 2 more lines, so the second last thing we need to do is factor out the dy dx from the left hand side. So when we factor out from the first term, we get minus 2xy. From the second term gives us plus 3y squared. And the last thing we need to do is divide across by this to get dy dx equals. See, the dy dx is multiplying. These are multiplying together, so to get rid of this thing, I divide. So I get y squared minus 6x divided by minus 2xy plus 3y squared. Alright, so We've done most of the heavy lifting at this stage. This is dy dx. Alright, so we're going to stick a box on that. Now, we are interested, this gives us the slope of the tangent. We are interested in the slope of the tangent at a particular point. So what we're going to do, we're interested in it at the point 1, 0. So we're going to fill in, at the point 0, 1. So we're going to fill in 0, 1. So add 0, 1. So we're putting in 0 in for x and 1 in for y. So we get 1 squared minus 6 times 0 over minus 2x by y plus 3 by y squared. So that's 1 on the dot line, because that there is 0, over 3, so that's 1/3. So the slope of the tangent is 1/3, that's 0, and that's 0. So this is equal to the m in the formula. That's the slope of the tangent. We already know that 0, 1 is the point on the tangent, so we can now find the equation. So the equation, y minus y1 equals m into x minus x1. If you multiply across by 3 to get rid of that, we get 3y minus 3 equals x, and that'll do. 3y minus 3 equals x. What we did there was we multiplied the left hand side by 3, and we multiplied the right hand side by 3. When we multiply the left by 3, we get 3y minus 3. When we multiply the right hand side by 3, the 3 is cancelled. So we just end up with x on its own. So 3y minus 3 equals x, that's the equation of the tangent. Alright, so just to run through it very quickly, once more, when you're looking for the equation of a tangent, you need to use y minus y1 equals m into x minus x1, because the tangent is a line. This is usually what we need to use. And the tricky bit is the slope of the tangent. Alright, so the slope of the tangent is given by dy dx, so we need to go and find the derivative of this. So because they're kind of mixed in together, you have y's multiplied by x's, you don't have y equals, you need to do implicit differentiation. And in most of the cases you will meet, there will be a bit of a product rule just to make things a bit more awkward. So that's what we have here. Each time we differentiate a y, we multiply by dy dx. So when we differentiate y cubed, we multiply by dy dx. When we differentiate y squared, we multiply by dy dx. Alright? You get everything with dy dx stays on the left, everything else goes to the right. You factor out the dy dx, and then you divide across by whatever's here in front of dy dx that you don't want. See, these are multiplying. So to get rid of this is multiplying by that. To get rid of this, you divide by this thing. Alright, and that's why you end up dividing the right hand side by it as well. Divide both sides by it. It cancels on the left, so you're just left with dy dx. It ends up on the bottom line on the right. And that is the slope of the tangent. Because we're just interested in it at one particular point, we fill in the coordinates at that particular point and we find out what the slope is. The point 0, 1, so 0 goes in for x, 1 goes in for y. So the slope of our tangent is 1/3. So the equation of the tangent, then you just fill it in, multiply across to get rid of any fractions. And that's it.